Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. In today's video on digital electronics, I shall teach you about the logic gates. Now, what is a logic gate? Well, a logic gate is a device that receives one or more electrical input signal and produces an output signal that depends on those input signals. Now, this is a definition you need to by heart in case it is asked for you in the examination. Also, what is written here is about the high and the low. Now, high and the low is the input or the output that will always be used as a part of your vocab when you're describing the logic gates. So, high can be either represented by 1 or on, and low can be represented by 0 or off. So, with this basic information in mind, let us now understand how to identify the gates and what are the truth tables for the respective gates. As you can see here, you have got the AND gate. Now, the AND gate has the alphabet D in it. So this D tells you that whenever you see the shape of the gate in the form of some D, then obviously it's going to be your AND gate. So the AND gate has a D shape symbol in it. So that's how you recognize your AND gate. And like you see on the screen, AND gate has got two inputs. I have labeled them A and B. You can use any alphabets. Output is C. So the rule is the output will be high if both A and B are high. That's how the logic goes. So now, which of the rows have got both the inputs high? Obviously, the last row has got both the inputs high. So the output is only going to be high for the last row. Everywhere else, the output is going to be low or 0, or is going to be off. Now coming to the OR gate. The OR gate again has a logic. Remember, all my logics are going to apply only for the output. So output is going to be high. When is the output is going to be high? When either A or B is high. And obviously, if both are high, the output is going to be high. So this is what you need to remember. So now, if my output has got to be high, at least one of the inputs has to be high. Now check the row where the input is 0. So the third row has the input 0. That means the output is going to be 0 only for that row. Rest everywhere else the output is going to be high, because the minimum condition is at least one of the inputs should be high. Coming to the next gate, which is the NOT gate or the inverter gate. One major difference between NOT gate and NOT gate and OR and AND gate is that both the other gates have got two inputs, whereas this gate only has one input and one output. So there's only one column for the input and one column for the output. It's very simple, the working of the NOT gate. It's an inverter gate. It reverses the input. So if the input is high, output is low. If the input is low, output is high. So write the opposite values, and that's how you make your truth table for the NOT gate. Now coming to the NOR gate. Now these are combination gates. I use this word combination gate to tell you that it is made up of two gates. So this yellow section here represents the OR gate. So this is my OR gate, and the blue section here stands for the NOT gate. So what you get is a output that is a result of the working of both the gates. So now let us see how it will work. Suppose I consider the first row. First row tells you when the input of A is 1 and the input of B is 0. Now this extra column I have drawn to tell you that this is what you should be doing in your mind. Okay? So, and what is happening in the mind is you're imagining what is the output of the OR gate. Now if either of the inputs is high, output is going to be high for the OR gate. So I'm going to write a high if there is at least one input which is having a high input. So now in these three cases, the output of the OR gate is going to be high. What is the NOT gate going to do to it? Is going to invert it. So if the output of the OR gate is high, the NOT gate is going to reverse it. So obviously in these three places, the output of the NOR gate is going to be low. So then that means if the inputs would have been low, the output of the NOR gate OR gate would have been low. And what does this NOT gate do? It reverses the input, so it will make it into 1. So the gate will function only if both the inputs are low, or they are 0, or they are off. And coming to the last gate, which is our NAND gate. Now as the word tells you, this is a combination of AND. So this is my AND gate, and ahead of AND is my NOT gate. So the same thing is going to happen. This is to be done in mind. So now the rule for the AND gate is what? Both should be high. So where are both high? Both are high only in this case, when input A is high and input B is high. So the output of the AND gate will be high. What is the NOT gate going to do to it? It's going to reverse it and make it 0. So when will the gate not function at all? It's only when both the inputs are high, this gate will not function. So in other cases it is going to function. So straight away put 1 1 1. So that's how you're going to predict the outcomes of the NAND gate. Okay, so well, this is all in today's video on the type of gates, and application based questions on the different kinds of logic gates will be dealt in the next video on logic gates. So thanks for watching my video. Please do subscribe to my channel if you like. Thank you.